I want to start with an activity that we actually did first when we talked about translation, which is before we translate entire phrases or expressions, just how you would translate individual words. So I'm actually going to stop the video here, and I want you to group all of these words in this graphic organizer. So for the example, some obviously is an addition word. You can create this graphic organizer in your paper. Go ahead and group all of the words. After you've grouped them, press play to actually check your answers. Okay, time to check your answers. You've already grouped them all. This is how I would have grouped them just very quickly. Difference is a subtraction word. Quotient is a division word. Less is a subtraction word. And is telling you addition. Minus is telling you subtraction, obviously. Add is telling you addition. Divide goes here. Is the same as is an equals word. Equals is an equals word. Cubed is a multiplication word because it really means 5 cubed, which means 5 to the third power, which is really 5 times 5 times 5. Twice is a multiplication word because it really means times 2. Tripled is a multiplication word because it really means times 3. Per tends to be a multiplication word, so if I go 5 times per day, that would be 5 times the number of days per. Now on this side I have product, the answer to a multiplication problem, more, addition word, plus, addition word, subtract, obviously subtraction word, multiply, which is right, I don't see it, I'm going to write it, multiply, is, which tends to mean is the same as, is equal to, also which means equals, squared, which is multiplication because it really means 5 squared, 5 to the second power, which is really 5 times 5. Half, which is a division word because it really means dividing by 2. If you cut something in half, you're dividing it by 2. Decreased, which is a subtraction word. And finally, of, which tends to be a division word. Okay, so that's how you would translate simple words from English to kind of the language of math. Now it's time to actually translate entire expressions. So we're going to look at expressions and translate them into an equation, which means there's going to be an equal sign in the answer. So if I want to translate this first one, 2 times a number plus 10 is 20. The first thing I'm going to do is just identify the information I see. I know I'm going to use the number of 2 times, so there's going to be an operation of times. A number, which means I need a variable, I'll go ahead and use n. Plus, that's an operation we're telling me addition. 10, another word I have, is one of my words for equals 40. So altogether, what that means is 2 times a number, which is 2n, plus 10 is equal to 40. I've translated that English expression into a math equation. Let's try one more example before I ask you to do it. 36 is equal to the quotient of 72 and a number, so I know we use the number 36, is equal to the quotient, so I'm going to be using division of 72, and a number, I'll call it this time b. To put all those things together, I have 36 is equal to the quotient of, so that means I need to be dividing 72 and a number b. This is the quotient of 72 and b, which equals 36. I've now translated that into an equation. Another way I could have written that would have been 36 is equal to the quotient of 72 divided by b, like that. But either way would have been correct. Okay, now I'd like you to try. Please translate these two expressions into equations. Stop the video here, press play when you're ready to check your answer. Okay, you've tried, so now it's time to check. See, 5 times the product of 2 and a number equals 14. Would have been 5 times the product of, so I have two words here that mean multiplication, 5 times the product of, so that means 5 times the product of 2 and a number, let's call that z, is equal to 14. So I need to have multiplication in here twice. So it's going to look like 5 times, I'll use parentheses, the product of 2 and the number z, so that's 2 times z, is equal to 14. So that's 5 times 2z equals 14. Another way you could have written this would have just been 5 times 2z equals 14. Now checking to D, the difference, that's subtraction, of a number, let's call it n this time, and 12 is 30. So if I want to translate that, the difference of a number and 12 means I need to subtract n minus 12, that's the difference of n and a number and 12, is equal to 30, and that would be my final equation. Hope you did well. Now it's time to solve one-step equations, which is a slightly different skill. We're going to be solving equations first with addition and subtraction. So the way that we introduced it here is that whenever we see addition and subtraction, the very first thing we're trying to cancel is the constant. The constant is a number that's all by itself, that is not being multiplied or divided, but is being added or subtracted. So in order to cancel the constant and get x by itself to isolate it, we're always going to add the opposite of the constant. So that means if I see 7, I'm going to add negative 7 to this side, and I'm going to add negative 7 to this side to cancel the constant. The reason I would do that is 7 plus negative 7 cancels out and equals 0. I've canceled my constant, and I have x left on this side. And 15 plus negative 7 is the same thing as 15 minus 7, which equals 8. And so my answer is x equals 8. To quickly check my answer, I should have 15 equals x plus 7. Instead of x, I should be able to substitute my answer of 8 and see if I'm right. 15 equals 15, so my answer checks out. One more example that I'd like to show you is with subtraction. So this time I have x minus 9. X minus 9 equals 60. So in order to solve this, I need to do the same thing as last time, which is add the opposite. For me to add the opposite, though, I need to kill subtraction first. This is really x minus 9 equals 60. I'll write x plus negative 9 equals 60. And now I can add the opposite. I'll add the opposite of negative 9, which is 9, to both sides. If I do that, negative 9 plus 9 cancel out and equals 0. I have x left over here. 60 plus 9 equals 69. I have my answer. In order to check it, I'll just check using substitution. X minus 9 equals 60. That was the original equation. I'll plug in my answer. Minus 9 should equal 60. If it does, I'm right. 69 minus 9 equals 60. So my answer checks out. I'd like you to stop the video here. Please solve these two equations. And then press play when you're ready to check your answer. Okay, you've tried those two problems. First, 24 equals x minus 20. The very first thing you should have done is kill the subtraction. So you have x plus negative 20. And then you add the opposite, so that's plus 20 and plus 20. If you do that, constants cancel. X equals 24 plus 20, which would have been 44. That's the answer you should have had. Next, h, x plus 15 equals 34. You need to add the opposite, which would have been negative 15. and add the opposite, which would have been negative 15. If you do that, the constants cancel, and I have x equals 34 plus negative 15, which is the same thing as 34 minus 15, which I believe would equal 19. And that's the answer you should have had for G. H, excuse me. Okay, one more slide, which is going to be for solving one-step equations with now multiplication or division. So we talked last time about solving equations that look like this. You don't see a constant that we're going to need to cancel. In this case, there's actually a coefficient we need to cancel. Anytime you have a number next to x, we need to cancel that number, the coefficient, by doing the inverse operation, so that if you see multiplication, you'll divide, and if you see division, you'll multiply. You'll use that inverse operation. Okay, so coming to I to solve this equation, I have negative 5 times x equals 40. In order to solve that, I need to divide, since I see multiplication, by the coefficient. So I'm going to divide by the coefficient, which is negative 5, and divide by the coefficient, which is negative 5. If I do that, negative 5 divided by negative 5 cancel, because that just equals 1. And 40 divided by negative 5 equals negative 8. And my answer is x equals negative 8. To check it, negative 5 times my answer should equal 40. If I substitute my value in, negative 5 times negative 8, and negative times a negative, does equal positive 40. Let's try one more. I have now division in this problem that says x divided by negative 9. Just for a little help, I'm going to rewrite it. X divided by negative 9 equals 4. This time, since I see division, I'm going to be using multiplication to solve. I'm going to be multiplying by the coefficient, which I see is negative 9. So since it's x divided by negative 9, I'm going to multiply both sides by negative 9. When I do that, negative 9 divided by negative 9 cancel, because that really just equals 1. So I have x is equal to 4 times negative 9, which equals negative 36. That's my answer. If I were to go back and plug it in to check my answer, negative 36 divided by negative 9, a negative divided by a negative does equal positive, and 36 divided by 9 does equal 4. And so my answer checks out. So the key takeaway here is whenever you have multiplication or division, you're going to use the inverse operation to solve it by multiplying or dividing by the coefficient that you want to get rid of. In the first problem, I wanted to cancel negative 5, so I divided by negative 5. In the second problem, I wanted to get rid of negative 9 by multiplying by negative 9. I'd like you to stop the video here. Please try these two problems. Press play when you're ready to check your answer. Okay, and it's time to check your answer. X divided by 4 equals negative 12. Since you have division, x divided by 4 equals negative 12. To solve it, you need to multiply both sides by the coefficient, which you want to get rid of, is 4. If you multiply both sides by 4, the coefficients cancel, and x equals negative 12 times 4, which is negative 48. Now L, you have negative 3 times x equals negative 15. Since I see multiplication, I'm going to be dividing both sides by the coefficient, which is negative 3. If I divide both sides by negative 3, my coefficients cancel, and x equals negative 15 divided by negative 3, which equals 5, which should have been the answer for. Okay, now it's time for independent practice. I'd like you to complete these 8 problems independently. If you get a blue ribbon for these, you should be ready to retake objective assessment 2B point 1 through 3. Good luck.